Oh, wait. Oh, oh my God. The computer's doing it. Okay. Whatever. I'll go with the computer. Okay. So logs. Do you guys want to go over a few? I'm going to go over number 7 today, a few of them, some log property things. Before we do that, are there any questions on, like, I don't know, the other class, for example, wanted to look at like 6H, evaluating, right? What do you guys think?
Sure.
Yeah.
Well, how do you feel about some of the simpler ones like this? Like, what's the natural log of E? It's 1. Because this is a very simple question once you understand what it's asking. It's saying, remember, natural log is log base E. So when you say log base E of E, that's what this is saying. It's like E to what power makes E? E to the first power makes E. In the same way, log base 5 of 5 would be 1, right? How about, what if I did log base 5 of 1 though? So the way you answer these is you go, log base 5 of 1, who knows the answer? 0. Why is it 0? Because you're asking 5 to what, so 5 to what power would give me 1? Well, 5 to the 0 power makes 1. You guys feel all right about that?
Mm-hmm.
Now, or even like say 6F. What's the log of 0.0000001? Did I get that right? Are there 5 zeros after the decimal? Let's see.
Yeah.
Yeah, so 10 to what power would give me this? So what you might look at is like, say, a pattern of like, here's 10 to the first power. And what's 10 to the 0 power would be 1.0. So imagine who remembers this back from the olden days of like learning your place values and stuff. Moving maybe when you did, what do you call it? Scientific notation. So here's 10 to the 1, so 10 to the 0, -1, -2, -3, -4, -5, -6 is what I had to do to get me 5 zeros between the decimal and the 1. So does that make sense? Not too confusing, right? Okay. Let's look at who got H? 6H. What's log base 32 of 16?
Oh, skip
You skipped it.
it.
Sounds like AJ's got it. Okay, so how did you figure that out, AJ?
Well, if you take 32 and put it to the 4th, it's 56.
Wow, thank you. Have you ever seen those memes of how to like draw a cat?
Yeah.
And it's like you start. It's like the first frame is like start with a circle for the body and a circle for the head, and then the next frame is like the perfectly drawn cat. Then just draw the rest of the cat, and you're good. That's what AJ just did to us.
Yeah.
He made us for TikTok. Okay, so here's what you do. Because if you can intuitively get this is 4/5, great. That's really good. That means you have a good understanding of how like powers and roots are working here. But most of us are going to have to do something like this. I'm going to call this quantity X. Whatever you are, I'm going to call you X. Okay. Now let's figure out what X has to be. Let's rewrite it as an exponent. So 32 to the X power needs to give me 16. Is everyone still understanding that? The key, if you're wondering, I say you got this on paper, but you're like, how do you do this in your head? The key is to understand that these are both powers of 2 and think, how do I take this and drop it down to 2 and then back up to 16? Well, to drop it down to 2, you take the 5th root, there's your 1/5 power, and then to get it back up to 16, you raise it to the 4th power. So anyway, the long way goes like this. You say 32 is 2 to the 5th power. So it's 2 to the 5th to the X, and 16 is 2 to the 4th, right? And what happens with these exponents if you have a power to a power? Okay. Now the key here, this is maybe a tricky argument, but I hope it makes sense, right? If 2 to this power is equivalent to 2 to this power, what does that mean about the powers? I'm saying these have to be the same number, right? This 5x has to be equal to 4, right? So I'd go 5x is equal to 4, which means the answer is 4 fifths. Well, by the way, we just solved for x. What's x? X is the thing we were trying to figure out originally. That's the quantity we wanted to know about. Is that okay with everyone? So that method will help you out. G is kind of similar to that. So is J. They're both powers of 2. All right, you guys ready to move on to our log properties?
Stay here.
Stay.
Not ready.
Why don't we stay on actually 7? Let's not move on.
We're not going to go past 7.
Okay,
That's
sweet.
for
Excellent.
sure. Okay. A little bit of background here. Who, just out of curiosity, how many of you guys, when you hear the phrase log properties, have like some inkling of like, oh yeah, I remember covering that?
We covered it.
We covered it while we were in quarantine,
Yeah, so.
so we
So
don't
we
remember
can cover
anything.
it. That's pretty much what it is.
Yeah, so we don't remember anything.
Okay.
remember something.
So I'm going to show you an example here that hopefully, in years past, I've gone over like a more rigorous proof of why these work, and I feel like for a lot of people it's just kind of like hard to follow. So I'm going to show you an example with real numbers, and hopefully this will like make it make sense why these properties exist. So, for example, what if I wanted to evaluate? These markers are terrible. He's got a little bit left in it, but look, I've thrown away so many markers today. Go ahead. Nothing but net. Let the record show that I made that. So what if you're trying to do log base 2 of 8 times 16? Okay. Suppose that was actually like a quiz question or something. You're like, oh, what's log base 2 of 8 times 16? Well, what do you notice about those two numbers? They're both powers of 2. Excellent. That's the key here. So I might go, my argument would be, well, let's see. 8 times 16 is like saying 2 to the 3rd times 2 to the 4th, right? Make sense? So then what happens to those exponents? They add up, right? You get 3 plus 4. And so then let's answer this question. Log base 2 of 2 to the 7th is what? Don't overthink it. I think you might be making it harder on yourself, right? 2 to the 7th would make 2 to the 7th, right? Like, for example, what's log base 2 of 2 to the 1000th? 1,000. Like, you don't have to know it. My point is, you don't have to know what 2 to the 1000th power is to know that log base 2 of 2 to the 1000th is 1,000. Yes? Did I lose you there?
Yeah.
Yes? Okay. What I'm saying is if you had log base 2 of 2 to the 1000, that is an insanely big number. We're not going to calculate that. But then what's the answer to this question? 2, so it's, you do a log, you say 2 to what power makes this? Well, 2 to the 1000th power would make that. Does that make sense?
Yeah.
So, what I'm getting at here is that this is 7. Okay? Where does 7 come from? 3 plus 4. Where did the 3 plus 4 come from? Well, this and this. So really all this turned out to be was log base 2 of 8. What's log base 2 of 8, guys? 3. That's where the 3 came from, right? And then So that's, yeah, so the thing, what I'm trying to show you here is that when you do this, you get, oh, really, the two exponents associated with these two terms get added up. That's where this addition comes from, is that exponentiation turning into addition. So the general rule is this. If you have log of A, sorry, log of A times B is log of A plus log of B. How do we feel about that? Do you guys see how this example gives us, doesn't prove that it's true for every, if you're looking for something more challenging, you could prove that this, for any base you might pick, and for any pair of numbers, any pair of positive numbers you might pick, that this would always be, that this property always holds. Okay, let's move on. Or how about this? What if I repeat the exact same argument, except instead of multiplication, it's division? Yeah, so let's see. So same idea. Let's say you had, I guess we could do, say you did like 32 and 8. Well, same idea. You'd have log base 2 of 2 to the 5th over 2 to the 3rd, which would end up getting you log base 2 of 2 to the 2. What's the answer to this? 2. And again, where did that 2 really come from? Well, the 2 came from 5 minus 3. So that tells me there's a subtraction happening here. Where did the 5 come from? It was the log of 32. Where did the 3 come from? It was the log of 8. Yes? Yes, no? Okay, so then the general rule is log of A divided by B is the log of A minus the log of B. Oh, sorry, my computer is. There's our other rule. So just like with exponents, right? Multiplication turns into addition and division turns into subtraction. So which shouldn't surprise you too much because logs are just a fancy way of writing exponential relationships. There's one more. Okay. What if we had log, let's just do base 2 again. Say you had 8 to the 5th power. Do you have to know what 8 to the 5th power is to do this problem? No. Even if you did, it's not going to help you very much because you're just going to end up with some pretty big number in there and you're going to be like, okay, great, I've got some enormous number. How am I supposed to know what 2 to what power makes that number? Well, so what you do, someone tell me, what would I do with that 8? 2 to the 3rd. Yep, write it as a power of 2. So 2 to the 3rd. So now what's happening? I get, right, so I multiply the 3 and the 5. That's the key here. What's the answer? What's log base 2 of 2 to the 15th? 15. Okay, now let's think hard. Where did that 15 really come from? Well, 5 times 3. So it was 5, that's where the 5 came from, times, where did the 3 come from? The 3 was the log, it was log of 8. Okay, so what's really interesting here is it shows you that you can take this number inside and raise it to a power, but really all that does is multiply the log value by that number. So generally speaking, you've got log of A to the B power is equal to, who knows this? What should we write right here? B times the log of A. Very good. Okay. there any questions? Okay, use those to do the first question on number 7. Take a minute, try it out. We'll go over the answer.
Just use it to solve A.
By the way, every question on here needs to be a sum of just like log x, log y's, and log z's with maybe multiples in front of them. You should never end up with, for example, if your answer for A has a log of square root x, that means you're still one step away from the actual answer.
Can we go over 8 again?
Over what?
Can we go over to 8 again?
8?
8.
7a?
A. Apple.
Yeah, 7a. That's what I'm doing. So who got an answer that they feel like they're at least a tiny bit confident with? No one even tried it?
Is it the top one?
You got something?
Yeah, log y squared plus log, or natural log y squared plus natural log y.
Oh, that's close. Where'd you get the squared from?
Squared side square root of the square root, you know?
Oh, okay. So what you're thinking of is if you have an equation,
Yeah.
a lot of times, so if you have like say square root of x equals 3, it makes sense to say, well, I can do stuff to both sides of the equation, so I can like square both sides. But right now we've got just an expression, so you're pretty much never going to be like squaring anything. So here's what you do. You say, let's use the first property. The first property says log of a thing times a thing is equal to log of the first thing plus the log of the second thing. Okay, this first one's a y, my bad. Okay, are there any questions on that first step? How that first step is an example of this property?
I understand.
You sure?
Yeah.
Okay. Now, this looks pretty good. We're not quite done yet, though. This guy's done. He's broken down. You can't get anything else out of that. But this guy is like saying log of x to the 1/2 power. Now, what can we do if we have log of thing to a power? Exactly. Like crazy. Okay, that 1/2 can basically move outside as a multiplier. So, all right. So what is this thing saying? This thing's saying that if you have the log of a product of a number and the square root of a different number, that's the same thing as the log of the first number plus half of the log of the second number. There you go, log properties. Let's look at, I don't know, maybe the one below it. By the way, I didn't write a little like n down here, but this, I hope it was clear. This is log base anything, right? This could be log base 7, could be log base, just be consistent, you're using the same base throughout. So for example, on C, you've got log base 3 of a thing divided by a thing. So first step would be which property? Division turns into subtraction. So it would be log base 3 of root x minus log of y to the 4th. All right, we just kind of saw this one, right? What's going to happen to this radical? He's a 1/2 power. He's going to move outside. So I have log base 3 of x. Everyone okay with that transition there? Minus. I forgot my little base 3, sorry. There we go. That's it. Pretty painless, right? Try B if you haven't already. There's a good chance that a lot of us will make a certain mistake. Yeah, it's a mistake that's very easy to make, and we'll address it. And then from here, it'll be kind of smooth sailing for a while because this is it. This is really all you got to know. Down the road slightly, I'll show you something nifty. How to change the base. That's down the road a bit. Anyway, so yeah, do B. See if you get what you get. And what do you think is the first step to look at? Yeah, it's the middle one. I have a thing over a thing. So I've got log of x squared minus log of y to the 6th c. Oh wait, what can I do with this guy? Break that guy apart using the top property. Now here's the thing, this is the part that the mistakes usually happen on. Okay, the final answer. Now, I hope you'd agree with me that having an answer without, if it's a sum of 1, 2, 3 items, it's probably better to have no parentheses if it's just a thing plus a thing plus a thing. So what's this guy going to turn into? Not 1/2, because the 2 is going to move outside. So we have 2 log of x minus 6 log of y minus, because these are both being subtracted, or you can think of that as the -1 being distributed over the addition, and you have 1. So there you go. So that's called expanding a log expression. So you expand it until it's just what they call like a linear combination, or just think of it as a sum of log x's, log y's, and log z's, where you can have a multiplier in front of each one. So how many log x's do I have? 2. How many log y's do I have? -6. How many log z's do I have? -. Oakley dokley, you guys feel like you understand? No questions? Stream.